Now let's have a look at the failure rate. What is failure rate? And people call it instantaneous. Instantaneous failure rate, or some people call it hazard rate. Which is the probability of failing after surviving up to time t in a small interval of time delta t. So if we write in the probability terms, that is fail in next delta t given survive to t. So this is actually, what is this? This is ft, right? ft2 minus ft1. So this is ft plus delta t and minus ft divided by rt. Why rt? Because this is a joint distribution. Joint distribution is you survive up to t and you minus it, right? Because you go beyond it. And then fail in the next delta t. This is actually the joint distribution of these two conditions. You survive to t and then fail in the next delta t. This is joint distribution. But you condition this will be probability survive to t. Probability survive to t, that means you're greater than t. That means that is rt. Am I making sense? So this is actually probability b given a equals to probability a intersect b divided by probability a. Now if we denote this as, this is a probability, okay? Probability survive to t and then fail in the small interval delta t. This is a probability, but it's not a rate yet. You know, speed, right? Speed, you march maybe a small distance, and then you divide it by the time it takes. That is the speed. So this is a probability it will fail, but it hasn't divided by delta t yet. So if we want to get ht is the rate, hazard rate or failure rate. Because you have this probability to fail in the delta t, and if you divide by delta t, that will become a speed. Make sense? It's like you march 10 meters in 1 second. Then 10 meters divided by 1, that's your speed. So here, this is a rate. And this will be ft plus delta t minus ft divided by rt. But you need to divide it by delta t again. So this will become a rate. Okay? So if we separate this will equals to ft plus delta t minus ft divided by delta t times 1 over rt. Okay? Now for this part, because the delta t is going to be small and small, right? Infinitely smaller. So this part, what will be this part? Limit delta t goes to 0, ft plus delta t minus ft divided by delta t. And this CDF, and then if you do this, what's going to happen? This equals to what? Yeah, this is derivatives, right? And if you have f prime t prime t is actually equals to ft. So when delta t goes to 0, this will equals to, it's actually equals to dft divided by dt. This actually equals to ft over rt. You see, if you take the PDF function divided by survival function, this will immediately become your failure rate at a particular time t. You got it. You got the failure rate. Okay? Now, in this scenario, what is the failure rate for exponential distribution? Failure rate. For exponential. Now, what is ft for exponential? Lambda exponential minus lambda t. What is rt? Exponential minus lambda t. Then what it will be ht? Lambda exponential minus lambda t divided by exponential minus lambda t. This is constant. Okay? So here is a note. Exponential distribution is the only distribution with constant failure rate. Okay? Huh?
Is this because of the memorylessness?
Yes, 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 yes. So this is the exponential distribution. If somebody say, "Oh, failure rate is constant," then it must. Then you can model it as the exponential. Exponential is the only one with constant failure rate. Okay. Now next, if we know the failure rate ht, what is ft? Suppose I tell you you have the particular failure rate, then can you derive the ft? You know, ht equals to ft divided by rt. So this is actually equals to f prime t divided by 1 minus ft. Okay. Now, if we know ht, what is ft? So this is a question. Obviously, we have that in that side. So we're going to do the integration in both sides. Okay. So we know that if we have integration of something, maybe f prime over f is actually equals to log f, right? This is the integration form. Now if we integrate this equation in both sides, what are we going to get? We're going to get minus log 1 minus ft. This is actually the right side, equals to 0 to t hx dx plus some kind of constant. Because if you do the derivatives, this is derivatives, right? So if you this is the integration 0 to t. If we take the duration, then this becomes ht. This will become 0. ht equals to this one will 1 over, right? 1 over 1 minus ft. Then you take the differential on the top. This will become, because you have minus sign, so you will see minus f prime t. Then you have minus sign over here, then positive ft, right? F prime t. So in this case, log 1 minus ft is actually equals to minus 0 to t hx dx plus k. Someone say, oh, it must be minus k, right? Because it's always constant, just k prime maybe. K prime equals to minus k. Okay, it's still constant. So then if you take the exponential to both sides, then 1 minus ft will equals to exponential minus 0 to t hx dx times exponential k, okay, k prime. But we know that if t equals to 0, what is ft?
0.
There's nothing fail, right?
Yeah.
Okay? So if you put t equals to 0, then this equals to 0, 1 minus this one, then what is k? What is k? So here, we have this condition, folks. We have this condition. Now we have this equation. We want to find k prime. This k prime. So if we make t equals to 0, this one will become 0, right?
Yeah.
And if t equals to 0, what is this one?
0.
1.
Right?
Is
0 and then 1, right? Exponential 0, 1. So this is 1 equals to 1. If this one doesn't equal to 0, then what's going to happen to this one? They don't equal to each other. So k prime has to equals to 0. So exponential k prime. Am I blocking the view? Okay, so this equals to 1, then k prime equals to 0. So far we got ft is actually equals to 1 minus exponential 0 to t hx dx. So this is failure rate and the failure function, the relationship. If you know the failure rate, immediately you got the distribution. Okay? Now let's do it again. If ht equals to lambda, constant failure rate, so derive ft. You see, if then this will become 1 minus exponential 0 to t lambda dx. Okay? So this equals to 1 minus exponential minus lambda t. Then ft equals to f prime t equals to lambda exponential minus lambda t. Obviously, what is this? This is, oh, this doesn't look good. This is exponential, right?